This tutorial is about transparent plastics with different surface finishes. Minimalistic imperfections will be applied using the real-scale cubic UV projection method, so you won't need to create UV coordinates via UV unwrapping. We'll use an evaluation scene with HDR emitter lighting, a product photography camera with depth of field, and a floor plane. But you can skip that part if you have your own ideas. Once you understood how the materials work like they do, you can easily swap color and refractive index for any other transparent plastic material. So let's look at the finished results. PC or polycarbonate shiny. PC shiny with random colors. PET or polyethylene terephthalate shiny with dust. CA or cellulose acetate shiny and aged. And CA shiny, aged, cloudy with scratches. Make sure that all your parts are properly detailed, because you can't render what doesn't exist. Correct draft angles, wall thickness and fillets in the appropriate places make a huge difference. Open Maxwell Studio and load a standard beginner layout using the Windows menu. Load the materials test scene and change the perspective viewport to textured decal mode, so you can see the photo studio lights and floor plane textures. This is a classic 4-point lighting setup that lets you appraise material properties rather well, that provides reflections and allows you to create different photographic moods with multi-light without having to re-render. The camera is set to HD format, so you have a large image to examine materials in detail. Using a long lens eliminates perspective distortion, and a suitably high f-stop provides a nice depth of field. Instead of pushing the lights to unrealistically high values, simply adjust the ISO and shutter speed to change the overall brightness, just like you would using a physical camera. Import the brick and minifigure OBJs and orient them either numerically or using the W and I keys like in Maya. Reset the transformations you applied so they won't interfere with texture mapping. Right-click in the viewport to set the focus. Activate the interactive renderer to get an idea about the lighting and depth of field of the scene. So let's make the 5 transparent plastics shown before. PC Shiny. Right-click in the materials list and select New Custom. Set the reflectance 0 and 90 colors to 0 and the transmittance color to 159, 3, 229. Set the attenuation distance to 7 cm. The attenuation distance determines how far light travels through an object before losing half its energy, which also influences the transmittance color's visibility. Set the roughness to 1 and the refractive index ND to 1.581 and keep the extinction coefficient K at 0. Activate Force Fresnel to maintain bright reflections for all viewing angles. You can find refractive indices and extinction coefficients for all kinds of substances online. In the Material Editor's Preview section, load the symbol scene and in the options set the sampling level to 20 and render time to 5 minutes, then click Update. If you want to save a material for future use, you want an accurate preview icon, so you or your colleagues know exactly what the material looks like. Because of the size of the symbol and its baked-in UV coordinates, and your objects having different dimensions and wall thicknesses, it is best to use the relative texture mapping method and keep repeat and bump strength as shown, not for the render, but only the preview icon. Drag the material onto bricks and drag Lego 208 Lightstone Gray onto minifigure, then click Render. PC Shiny with random colors. Import Lego bricks groups on and hide the previews, because for random colors we need individual objects, not a joint mesh as before. Right-click in the materials list and select Clone Material to make a duplicate. Change the attenuation distance to 3.5 cm. Map transmittance with a random color procedural. Change the random seed to 23 and set the hue range to 50-200, the saturation range to 150-200 and the value range to 50-100. Then click Update. Reduce attenuation to 1.75 so the transmittance color will become visible within the thin-walled Lego bricks. Drag the material onto bricks, then click Render. PET shiny with dust. Right-click in the Materials list and select Clone Material to make a duplicate. Change the transmittance color to 172, 38, 218, attenuation to 9 cm, ND to 1.636 and roughness to 5. To apply dust particles only in some places, right-click to copy the dust layer from ABS Shiny with scratches and dust and paste it into the layer stack. Change the texture mapping method to relative and the repeat to 2x2 so it shows up in the material preview icon. Drag the same texture to the Materials Global Properties Global Bump slot, repeat it 2x2 to match, set the bump strength to 3 for the moment, then click Update. Change both opacity and bump texture maps mapping method to meters and the size to 10 by 10 centimeters because this is what the texture represents in the real world. Lower the brightness by -30 to remove the faintest dust particles, set the global bump strength to 0.3 and reduce attenuation to 4.5. Drag the material onto bricks. You will get an alert message, so what is that telling you? When you set a texture's mapping method to meters and then use real-world texture dimensions, the object's UV set projector must change accordingly. So select Lego bricks, go to Geometry in Object Parameters, choose Cubic as projection method and click Normalize, then click Render. CA Shiny and Aged. Right-click in the Materials list and select New Custom. Set the Reflectance 0 color to 43, 57, 145, the Reflectance 90 color to 0, and the Transmittance color to 43, 103, 171. Set the attenuation distance to 8 cm. Set the roughness to 12, because CA is softer than PC or PET. Set the ND to 1.47 and keep K at 0. Activate Force Fresnel to maintain bright reflections for all viewing angles. Then click Update. Reduce attenuation to 2 cm, what it should be for thin-walled Lego parts. Drag the material onto bricks, then click Render. CA Shiny Aged Cloudy with Scratches. Right-click in the Materials list and select Clone Material to make a duplicate. Set attenuation to 20 cm for the moment and map transmittance with a noise procedural. To make the procedural's UV projection independent of scale and orientation of objects, select World Coordinates. Set the background color to 43, 103, 171 and the noise color to 43, 93, 51. Set detail to 66, low clip to 0.45 and high clip to 0.55. While the detail value controls the size of the noise granularity, low and high clip allow you to adjust the contrast, the transition between background and noise color. Right-click and copy the noise procedural and paste it into the roughness slot. Change the background color to 0033 and the noise color to white. The reason for that color is that pure white denotes our maximum roughness of 40. while near black is equivalent to a roughness of 12, which is the original shininess of the material we cloned. Set roughness to 40. In the material's global properties, load the noise micro-scratches N texture into the global bump slot and repeat it 2x2 for now, so it shows up in the material preview icon. Set the bump strength to 33 and activate normal mapping, then click Update. Set attenuation to 2 cm. Change the noise micro-scratches N textures mapping method to meters and the size to 15 by 15 cm, because this is what the texture represents in the real world. Drag the material onto bricks, then click Render. And now it's your turn. Thank you for watching and listening.